Hey, welcome back to the channel. If you remember last week, we used Terraform and Ansible to set up and install kubeadm on AWS EC2. Well, for this week's video, I thought why not do exactly the same, but manually using the AWS CLI. So if that sounds interesting to you, we'll stick around after the intro. Let's go. Okay, so let's recap what we're going to be building, right? Before we start, a few prerequisites. Number one, you've got an AWS account, of course. Number two, you've got the AWS CLI configured. Number three, you've got Ansible installed. And finally, you have a basic understanding of Bash and Bash scripting. Now, as for the networking resources, we're going to create a custom VPC for ourselves. We'll create a subnet. Then we'll create an internet gateway. We'll have a root table with a custom root declaration, and then we'll essentially make that subnet a public subnet. We'll add 4 security groups, one for the common ports, SSH and HTTP and HTTPS, one for the control plane, one for the worker nodes, and then one for Flannel. As for the compute resources, we'll create a key pair, right, to connect to our instances, and then we'll create 3 EC2 instances, one for the control plane and then 2 for the worker nodes. Again, keep in mind that the control plane will be a bit bigger than the T2 micros, because this is what Kubernetes requires to, this is what kubeadm and Kubernetes requires for the control plane. So we'll use a T2 medium. We're not going to use it for very long, so it's not going to cost us $1 million, right? And then finally, we have provisioning, where we'll create an Ansible inventory using the IP addresses given to us by AWS. I'll walk you through the Ansible playbook once again to show you what exactly we're going to be installing and how exactly we are going to set up kubeadm on these instances. And then we'll run a few tests using kubectl. So let's crack on with the code now. Now, just a quick note on the AWS CLI and the output formats, right? In the documentation for the AWS command line interface, if we scroll to select how to select output format, so by default, what AWS does and CLI does, it outputs, I think, text or JSON, right? And so if you go to your config file on the home directory .aws/config, you will be able to change this. Mine is set to YAML. Most people set it to JSON, but you can thankfully override this by tacking on the output flag at the end of each AWS command. And so essentially what happens is when you run an AWS command, it hits the API, right? So it's essentially configured to hit the API, and the API returns data, and then we can filter that data using query, using the -- query parameter. And I think they give us an example. So filtering nested data, right? And so the following example shows all attachment information for all volumes. This is useful if you want to extract info. Let's say, for example, we create a VPC, and then we want to save the VPC ID into a variable. Well, we can do this with the query volumes attachment, right? So I just wanted to point this out before we actually start working. So now we can. So I'm inside my demos directory, and I have created an EC2 Gate CLI subdirectory, inside of which I have 2 directories. One is called Ansible and one is called Files. So Ansible is going to have our playbook and inventory, and then the Files directory will have a containerd, configuration, and the host file that we create. So we can crack on now with our first resource, and that's going to be our VPC, right? So the way we're going to do this is we're going to do export AWS VPC ID, right? And that's going to be equal to AWS EC2 create VPC. We'll pass a CIDR block of 10.0.0.0/16, and then we'll query for the VPC.VPC ID, right? And we'll set the output to text, okay? And so to recap, so we call the EC2 API, right? We call the create VPC API, and then we pass it to CIDR block. We extract the VPC ID from the returned response, right? So let's run this. All right, so we've got no errors. So if we echo AWS VPC ID, we have our VPC ID. Brilliant. If you want to know all the available commands for a particular service, you can run AWS, let's say for example EC2, and then we can do help, right? And then this will list every single available subcommand, or we can do AWS EC2 and then add some rubbish, right? And then this is going to list essentially all the available commands. So yeah. And then of course for each command, let's say for example, withdraw bioIP cider, we can do that and then run the help command. And then we get essentially a man page with the necessary and required arguments and stuff like that. So I'm not going to bore you with typing. I'm just going to copy paste from now on, right? So we've got our VPC. So the next step is going to be to enable DNS host names for that VPC. So we're going to do just that, right? So AWS EC2 modify VPC attribute. We pass it the VPC ID, and then we enable DNS host names, and we set the value to true. There we go. That's good. Right, so that's for the VPC. Okay, next up we need to create our subnet, right? And just like for the VPC, we're gonna have to save the subnet ID. So this is what it's gonna look like, right? AWS EC2 create subnet. We pass it the VPC ID. We give it a cider block, and then we extract the subnet ID, and then we do output text. Because if we don't do that, we'll get a string representation of the text. So with the double quotes, we don't want that. So we can run this, and if we echo AWS subnet public ID, we've got our subnet ID. Brilliant. So now that we have a subnet, we need to enable the auto assign IP on launch, right? And what this is going to do is it's essentially going to allow our subnet to attach a public IP address to every instance that's created within it. So again, AWS EC2, we modify the subnet attribute, we pass it the subnet ID, and then we tell it to map the public IPs on launch, right? Now what we need to do is we need to create an internet gateway as per the list. So again, we're gonna have to store the gateway ID. So we're gonna have to do this. So export AWS IGW ID, and this is going to correspond to AWS EC2 create internet gateway, and then we extract the internet gateway ID like so. We echo our AWS IGW ID. There we go, we've got it, brilliant. Moving on to our root table. All right. Again, we create a root table. AWS EC2 create root table. We pass it the VPC ID, and then we extract the root table ID. That's good. And this is useful because we're going to add a route to that root table. Before we do that, we need to, of course, attach our internet gateway. We, of course, need to attach our internet gateway. So to our VPC, of course, right? And so now that we've attached our internet gateway and that we've got our root table, we can create a root. And as you can see, it returns true, which means we're good. Okay, so that was it for the roots and the gateways. So the last thing for us to create in the networking department is the security groups, and this is going to be done in two steps. Number one, we create a security group as a standalone resource, and number two, we attach ingress rules to that security group. So let's first create security group, like so, right? So what we do is we export the security group ID. We run AWS EC2 create security group. We pass it the VPC ID. We give it a group name. We create a group ID, right? And then we output the text. We also add a description. That's a mandatory. Flag. So if you remember from the recap, we need to create 4 security groups, and these are going to correspond to essentially 4 ingress rules. So first, we'll go with the common ports, which is going to be 22, 80, 443, and 10250, right? And we save this as an array, because what we're going to do is we're going to loop through that array, and we are going to, for each port, we're going to create an ingress rule, as you can see here. It's created them. There we go. And so for port in common ports, do AWS EC2 authorize security group ingress. We pass the group ID. So that's the security group ID we created. We pass the protocol. we give it a CIDR. So for us, it's going to be the internet, and then we pass it the port. And as you can see, we've got port 22, port 80, port 443, and port 10250. We're going to do the same thing for Flannel. So for Flannel, we create the 2 UDP ports, and then we do essentially the same thing, except we have set the protocol to UDP. So that's good. And if this is going over your head, I would encourage you to refer to the previous video where we did all of this in Terraform. Now this is going to be for the control plane ports, right? So these are the etcd ones. This is the API server, kube scheduler, and all the rest of it. So boom, we're doing the same. We're back to TCP, of course, right? There we go. And then the last one is a bit more involved, isn't it? That's going to be for the node port services, right? As you can see, we add an IP range from port 30,000 to 32,767. And this is going to be used by Kubernetes when you create node port type services. And boom, we're good. So that is it for the networking services. In fact, let me see if I can show you what we've created in the console. All right, so I'm in the dashboard now, and if I navigate on the left navigation bar to security groups, as you can see, we've got our security group created. And if I look at the inbound rules, you can see this. So we've got everything we need, and that the description is the node service ports. We could have added the description for the rest of them, but it's okay because we know it's fairly evident what they do. So notice we don't actually have instances yet. So if we go to the dashboard, we've got 0 instances running. But for the fun of it, if we go to the VPC really quickly, I can show you that we have our subnet too. And there it is. That's our subnet here, 10.0.1.0. And then we've got our VPC here, 10.0.0.16. So the first step to create an instance on AWS is to, of course, create a key pair, which is going to be used for authentication inside the EC2 instance, and it's going to be also used by Ansible to provision our instances. So we'll create our key pair like so. So we export the name, right? So we give it a name, kubeadm, and then we do AWS EC2 create key pair. Pass the key name, we create a key material, and then we output the text. So we output the content of the key, and we output the content of the key inside a file called kubeadm.pem. So if we ls now, we've got it here, and then we chmod it. We change the permissions to 400, right? So it's only readable by us, like so. kubeadm, and it's only readable by us, and it's a private key. All right, so we have everything we need now to create our instances. So let's start by creating our control plane. All right. So we run AWS EC2 run instances. Image ID is going to be the AMI of our Ubuntu image that we found in the console. Instance type is going to be T2 medium. We set the count to 1. We pass it the subnet ID. We pass it the security group ID, right? And then we associate a public IP address. We associate our key pair, right? And then what we do is we query the instance ID, and then we output that into text. So if we echo control plane ID, we've got our control plane instance ID. Brilliant. So we're going to do the same thing now for our worker nodes. It's going to be much of the same, except the instance type is going to change to T2 micro, and the count is going to be 2. And again, if we echo worker nodes ID, we've got this. This is brilliant. So now what we need to do is we need to copy the public IPs to our hosts file, right? Because again, we have a files directory, but we've got nothing in it. So what we'll do is we will do exactly that. So we'll echo master. So master is going to be the name of our master node, control plane node. AWS EC2, describe instances. We pass the control plane ID. We extract the public IP address, and then we set the output to text, and we plop that into our hosts file. Right. So if we cat now, if we cat files hosts, we've got our IP address. Brilliant. Perfect. Before I do this, I'm going to add a tag to our instance, just so we can recognize it at a glance in the console. Right. Perfect. All right. So we'll do the same for the worker nodes. And again, much like we did with the security group, we'll have an array. So we'll create a loop like so, okay? And inside that loop, we're going to do the same thing we did for the control plane, i.e. extracting the IP address. So the query here is going to be reservations, okay? It's going to be reservations dot instances. Again, we want to extract all the instances, and for each instances we want to grab the public IP address like that, and what we want to do is we want to output as text, and we append that to files hosts. Right, fair enough. And then we create tags for each of these worker nodes. Hopefully now we should be good. Yes. So let's cat files hosts. Boom. We've got our IP addresses set up in our hosts file, which is good, because now that means we can finally start provisioning our instances with Ansible. And now that we've got everything set up correctly with our instances, it's time to provision them. And so, as I said, we'll be using Ansible for this. And so first thing we need to do is create an inventory file. So inventory.yaml. Now, most of the inventory files that I've seen online use the INI format, but I find YAML to be much more easier to work with and easier to read. So we'll open the host file in a separate pane, and essentially what we have is we have two groups of hosts, right? So master node and one group for the master node and one group for the worker nodes. Right, so we specify the hosts for each group. So that's going to be worker 0, and we label them. So worker 0, worker 1, and up there it's called control plane. Each of these in fact, so we add a vars attribute, a vars sort of what do you call it, section, right? That's gonna have all the variables that will be common to all hosts. In our case, it's going to be Ansible user, and Ansible user corresponds to the user, the SSH user that Ansible is going to run the command as, right? All the commands as. So now we need to essentially populate the file. So let's go. So that's nope. So the control plane is going to take the master. Oops. Control plane is going to take the master IP. Worker 1 is going to have its own IP. Worker 0, sorry, and then worker 1 will have its own IP. Brilliant stuff. So the Ansible user is going to be Ubuntu, and the node host name is going to be master. Right? Okay. And then all we have to do now is create the playbook. All right, so I've got my playbook now. It's essentially the same. It's exactly the same as the one we had in the previous video with Terraform. And so again, so it does exactly the same thing, right? So it installs the prerequisites. We set the host name. We copy the host file. What do? We disable swap. We do everything there is to do with the kernel modules. We install containerd and Docker. What else do we do? We set it up correctly. So we set up the config file, we copy it, and then we do all the kubeadm stuff. So we download Kubernetes, we download the Google Cloud public key, we install kubeadm and kubectl, and then and then the control plane node, right? Because you can see hosts master. So whatever tasks run under this sort of sub playbook, these tasks are only going to be run against this host. And so we do kubeadm init, right? We create a kube directory, blah blah blah. We install flannel. We copy our kubeconfig file locally. So kubeadm will generate a kubeconfig file, but it lives in the server, right? So what we want to do is we want to fetch it, and then we'll copy inside temp kubeconfig. We generate a join token for our worker nodes, and then we save that to a variable. And then all worker nodes will essentially just join the cluster by using the join command that we saved previously, right? So now that we've got this all set up, all there is for us to do is run the playbook. And so we'll do Ansible playbook -i is going to be Ansible inventory. The playbook is going to be Ansible playbook, and the private key is going to be our kubeadm.pem, right? And so now we should run this, and we're just going to look at it and watch it do its magic. And it's done. Brilliant. So everything has been installed now, so the playbook ran without any issues, and hopefully we should have a kubeconfig file under temp. So if I cat temp kubeconfig config, we have our kubeconfig file. And if I look at the server, so the IP address, I think it corresponds to, yep, it does. Right? It corresponds to the IP address of our control plane node, which means we can realistically do kubecolor or kubectl, I guess, nodes. Alias k equals kubecolor, k get nodes. Yep, so we've got our nodes up and running. So let's test this out. Let's test if flannel works, right? So we'll create a deploy. So okay, create deploy demo. Image is going to be nginx alpine, and we'll have 3 replicas, right? So if we do k get deploy, right, all of them are ready. Okay, all the pods are ready and they're running. Brilliant stuff. So now we'll expose that service. So we'll do k expose deploy demo. We'll pass it a name, and we'll call it demo svc. The port is going to be 8000. Target port is going to be 80. Yep, like so. So we should have a service. Yep, demo svc. There we go. And so presumably now, if we do k run temp image, k run temp, if we run a temporary pod, right? So k run temp image is going to be again nginx alpine rm -it, and then if we do let's see, curl http demo svc colon 8000, we should have something. So yeah, I don't know why it wasn't working. So if we do k run temp 2, image is going to be nginx alpine rm-it -restart equals never, and if we curl http demo-svc :8000, we should get our response. So that's good. It's brilliant. This is exactly what we needed. So everything works fine now, which is good. And so all there is for us to do now is essentially delete all of the resources, right? So we'll do that. Because this was done manually and we don't have a magic command like terraform destroy, we're gonna have to do everything again by hand in reverse order of creation, which means we're gonna have to first delete the instances. Again, I think we call it key name, like so. Oh, is it key name? Nope. All right, fair enough. Do kubeadm. Perfect. So next we need to delete the security group, right? Like so. Now we need to detach the internet gateway. So AWS EC2 detach internet gateway. We pass the gateway ID and then a VPC ID. So we detach it. Now we can safely delete the internet gateway now that it's detached, because you can't do it otherwise. So delete internet gateway ID. Brilliant. We need to delete the root table. So first we need to disassociate the root table by passing the association ID. Echo AWS association. Oh, we've got an error. We're gonna have to set that correctly. I made a mistake. There we go. Brilliant. So now we can delete the root table. There we go. AWS EC2 delete root table ID. Perfect. Now we can delete the subnet. AWS EC2 delete subnet. We pass it the subnet ID. There we go. Perfect. And finally, we can delete the VPC by passing the VPC ID. And that concludes our little adventure with the AWS CLI and kubeadm. So if you enjoyed the video, give it a like. If you have any questions, you can leave them in the comments down below. I will be most happy to answer you. Don't forget to follow me on Twitch at AyoFisher. You can also follow me on Twitter at AyoFisher. And yeah, until next time, take it easy.